All right, so we are going to be multiplying binomials. And this goes to really, I should change this to, we're going to multiply polynomials. And it's just going to happen that all the cases that we're going to be looking at, all the examples, just happens to be a binomial times a binomial. Now, if we take a look at a question, it looks rather different. Now, contrast this to a monomial times a binomial, right? Remember that brackets, sort of in between brackets, it's implied 3 times this quantity, whatever in brackets. So over here, we're going to be multiplying this thing by this thing. All right. So it's really not a monomial times a binomial. It's a binomial times a binomial. And really, we could read the above, and the above is great information, right? When multiplying binomials, we multiply each term of one binomial to both terms of the other binomial, then we combine any like terms. There are 2 strategies. Split one of the binomials to create a multi-expression operations expression, or we could multiply first 4 things. First, outside, inside, last. So first terms, outside terms, inside terms, and last terms. So this is called FOIL. And you'll also always hear people say, well, I just FOIL it out. So here's what FOIL looks like. So you multiply the first terms, then you multiply the outside terms, and then you multiply the inside terms, and then you multiply the last terms. Now, I don't particularly like FOIL simply because it doesn't advance our math understanding. So, for instance, FOIL doesn't work with a trinomial times a trinomial. Instead, I like to look at it like this. We have a polynomial on the left and a polynomial on the right. Each term of each polynomial needs to kiss every other term of the other polynomial. So let's maybe do that in action. So x, it takes a look at the other polynomial and needs to multiply both terms of the other polynomial. And so that's the first term of the first polynomial. And the second, there's our second term. I need to multiply that term, 2, needs to multiply both terms of the other polynomial. And I get it that what I just did was FOIL, but really it's helpful when your polynomials get a little bit larger. We don't need to change up the strategy. All right. So let's do this first example. So I'm just going to get rid of this, and I'm just going to multiply x plus 2 times x plus 1. So x needs to be multiplied to both those terms, needs to kiss the other terms. So what we have is x times x, and that gives me x squared. And x times plus 1 gives me x. Now, what we can do is we can take 2. Now, this is my second term of my first polynomial. It needs to kiss every other term, the other polynomial. So 2 times x is 2x. 2 times 1 is 2. So then we collect like terms, and this ends up being x squared plus 3x plus 2. Well, fair enough. There it is. Another way that we're trying to look at it here, and you can also do it this way. You can say, I have x plus 2, and I need to multiply it by x plus 1. What I could do is I could split this up into, so it looks like this. x times x plus 1. And then plus 2x plus 1. And you can split it up like that and carry out your multiplications. And you would end up with the same answer. So really take a pick. So I much prefer that first way. That first way is always going to help me out. Okay? So 3x plus 2 times 4x minus 7. So what I would get, if I was to FOIL it, is 3x times 4x, 3x times 7, and then 2 times 4x, and 2 times minus 7. And if I clean this up, this would be 12x squared minus 21x plus 8x minus 14, or 12x squared, 21x plus 8. Now I'll try not to mess this up. I think that's minus 13x minus 14. There we have it. So that's what it looks like here. But again, let's maybe look at it. I could have split it up like this if I wanted to do multi-operational. I could say 3x times 4x minus 7, right? And then I could say, well, that's 3x times the brackets plus 2 times 4x minus 7. And if I wanted to do that, should end up with the same answer. All right. So C. What I'm going to do is, like polynomials, I'm just going to treat these in blocks like this. So 2x times 2x, 2x times negative 5. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is 10x. 5 times negative 5 is negative 25. So my overall answer should be 4x squared minus 25. And by the way, as we'll see later, this is called a difference of squares. What two quantities give you a difference of squares? The conjugates, what we see here.